If we look at these two equations that I've numbered 1 and 2, we see that it would be fairly easy to eliminate the z's in this equation simply by changing the sign of either the first or the second. So let's consider doing just that. We'll rewrite this one as 4x minus 3y minus z equals 2. So we'll make no changes to that. But we will multiply this one by negative 1. And that will make it 2x minus 4y plus z equals negative 2. Now adding helps a little bit because one of the variables is going to add away. We'll end up with 6x minus 7y equals 0. Let's call this equation A. It's sort of a second generation problem. It has two variables, just x and y. Now that's fine. Now we can go back and look at the equations again. And we're going to want to do the same thing over again, only this time we're going to look at a different pair. We could look at 1 and 3 or 2 and 3 and again try to eliminate the same variable, in this case, z. It looks like we could do that easily by taking the second equation and multiplying that by 3. That would give us negative 6x plus 12y minus 3z equals 6. Multiply every term, including on the other side, the constant, by that number. And then we'll look at x minus 6y plus 3z equals negative 5. This will give us an equation which for now we'll call B, and we'll get it by just adding these equations together. That will give us negative 5x plus 6y, z's drop out, equals 1. Okay, we have two equations now, x with x and y in it. And our best bet now then is to combine those two equations, because what we want to do is find the solution to this 2 by 2, it's called, system. And let's see what we would have to do to make that happen. If we have negative 5x and we have 6x, we could multiply one by 5 and the other by 6. So we'd want to multiply this one by 5, wouldn't we? When we do that, we'll wind up with 30x minus 35y equals 5 times 0 is 0. When we multiply this equation over here by 6, we will have negative 30x plus 36y equals 6. Notice that we have opposites here on x, and we end up with negative 35y plus 36y is just y equal 6. Well, now we know that y is equal to 6. What should we do with that? Now we're going to do what's considered back substitution. We're going to go back through the problem again, just the way we came. If y equals 6, and this is true, then negative 5x plus 6 times 6 equals 1. Negative 5x plus 36 equals 1. Negative 5x equals negative 35, so x equals 7. We're just solving the 2 by 2 system, and now we have x is 7, y is 6. What should we do with that? Well, we back substitute one more time. We're going to go all the way back to one of the original equations and substitute 7 and 6 in for that. So let's go back to number 1. 4 times 7 minus 3 times 6 minus z equals 2. 28 minus 18 minus z equals 2. Let's bring the z over to this side and take the 2 over there, and that'll make z equal to 8. Our answer to this rather complicated looking process is an ordered triple, which in this case is x, y, z is 7, 6, 8. 7, 6, 8. And we can write it like that, or we can just write it neatly, x equals 7, y equals 6, and z equals 8.